Hi, we are from Group K. So, my name is Nur Shahira. My other group member is Sahira, Putri Narila, Farah Wadina, and Sumaya. So, the first step is we need to generate 50 random samples from 84 data that are given to us, and we use generator online. So this is a 50 data that we get. After that, we classify the data into 4 groups, which is location 1, location 2, location 3, and location 4 for enable us to do the others question.
Hello everyone, my name is Zahira Makaraju and I will be explaining on the B part 1, which is describing the data and presenting the data graphically. Following will be the numbers generated from my team for the 3 samples BOD, DOC and SFS. And in order to plot the graph, we need to find the mean, standard deviation and the variance for all the 3 samples by using their respective formulas. So the mean for the BOD has already been found for the location 1, 2, 3 and 4, and following will be the standard deviation and variance for BOD, and followed by the mean for DOC by using the formula, and also the standard deviation and variance for DOC by using the formula, and the mean for SFS, and also the standard deviation and variance for SFS. Now, in order to plot the graph, I have chosen the clustered column chart. So based on the chart for BOD, the highest location is location 4, which shows that location 4 has the highest oxygen being dissolved, and the lowest would be location 3, whereby it has the least amount of oxygen dissolved. For the standard deviation, location 1 contains the highest standard deviation, which shows that the range of values are spread wide. For the location 2, it has the least standard deviation, which shows that the values are close to the mean. Now, following is the graph for DOC. For DOC, the highest mean value is location 2, which shows the highest carbon dissolved in the water sample, and lowest is location 4, which shows that it has the lowest carbon dissolved. For standard deviation, location 3 has the lowest standard deviation, which shows that the values are closer to the mean, while location 2 has the highest standard deviation, which shows that the values are spread far away from the mean. Now, following is the graph for the SFS chart. For the SFS chart, the highest location is location 2, which shows that the BOD reading is highly affected by the SFS factor. And the lowest is the location 3, whereby it shows that the BOD reading is least affected by STD because it contains the least mean value. For the standard deviation, location 1 has the highest value of standard deviation, which shows that the values are spread far away from the mean, and location 2 has the least value, which shows that the values are closer to the mean. So that's it from me, and thank you very much.
Hi, I'm Putri. I will explain about question B to Roman. Test at 5% significant level if there is a difference on DOC reading between location of water sources. Write the ANOVA model and its assumption. So this is the data that we get for DOC reading in 4 location of water sources. So the solution is model you can write like this or just like this, and this is the assumption that we get. Next hypothesis, H naught equal to mu1 equal to mu2 equal to mu3 and equal to mu4. H alternative equal to mu I not equal to mu j for at least one ij. We need to calculate SST, SSRT and SSE. So this is the way how we get SST, and the final answer is 5.97172. And this is the way how we get SSRT. The final answer is 0.78855. This is the way how we get SSE, and the final answer is 5.18317. So this is the summary, and this is the ANOVA table that we use by using Excel. So you can check whether your answer is correct or not. And this is our F test, and this is our F alpha. As we know, alpha was given is 0.05. So F 0.05346 equal to 2.81. So the conclusion, reject H naught if F test greater than F alpha. So F test is 2.33275 is less than 2.1. So, fail to reject hash null. There is no significant difference on the OC reading between location of water sources. That's all from me. Thank you.
My name is Farah, and today I'll be presenting the linear regression analysis. This is the data that we have obtained from the appendix given, and I have decided to use SFS as x-axis and BOD as y-axis. From the data we generated, we can plot them on the scatter graph to see and also to test whether the x and y have a linear relationship between them. For the linearity test, first we have to come up with a hypothesis. H null is beta equals to 0, H alternative is beta not equal to 0. And from the test statistic that I got from the Excel, which is the summary output, there is quite a lot of information that we got here. So we can form a linear regression model, which is y equals to 1.6401 minus 0.0004x. I got this information from this part. Intercept is actually the alpha, while SFS is actually beta. We can simply put the values here into the regression model. And also from the highlighted part here, these are the decision rule that we can use. But for today, as for decision rule, we decided to use significant f to compare with the alpha given. Our significant f value is 0.8035, which is bigger than the alpha given, 0.01. From this, we can fail to reject H null. For the conclusion, we fail to reject H null, meaning there is no linear relationship between SFS and BOD. From the regression analysis, we can obtain coefficient of correlation by square root r squared 0.0013, which we will obtain r equals to 0.0361. However, since our slope is negative, we can say that our r is negative 0.0361, and it is close to 0, meaning that there is no linear relationship between SFS and BOD. That's all from me. Thank you.
My name is Naomi Sulong. I'll be presenting to you our last question, which is BOD rating are assumed to have normal distribution with mean 1.5 and variance 0.135. By performing goodness of fit test from the result, comment if the assumption is true. We have the generated data from earlier of the video, so I proceed on how to do goodness of fit test. First, we have the hypothesis. Hypothesis, we have H null data follow normal distribution. H alternative data does not follow normal distribution. The second step is test statistic. We have the mean 1.5, variance 0.135, alpha 0.05 from the question, and this table must have also frequency, expected frequency. This is all to get the chi-square value. Okay, how to get the expected frequency is by using this formula or theorem, but it is valid only when the value is at least 5. So this value, it does not exceed 5. This is why I combine the value. So when you combine the value of expected frequency, you must combine the value of observed frequency too, and then calculate chi-square by using this formula. Next, we have decision rule. Decision rule for goodness of fit test, we have only one, which is reject H null if chi-square is bigger than chi-square alpha k minus unknown parameter minus 1. Unknown parameter is 0, and k is our number of categories. We can see from the test statistic, which is 6 minus 1, which is 5. So chi-square we got from the test statistic, which is 23.0391. We got chi-square from the table, 11.0705. So from this, we can see that chi-square test statistic is bigger than chi-square alpha k minus unknown parameter minus 1. So the last step, which is the conclusion, we reject H null. Data sample does not follow the normal distribution. That's all from us. Thank you.